Let me show you how to differentiate using the first principle. Okay, let's say we have a function f of x is equal to 5x squared. We want to differentiate and find dy by dx using first principle. So, step one, let's start off using the first principle formula to kind of do it. So, f of x, or differential of the function that we have at the moment, is equal to the limit as h tends to 0 f bracket x plus h minus f of x all divided by h. Now, this is basically the formula from first principle. We're now going to substitute in our f of x function into here, and we're going to differentiate and go along with using the first principle. So, how's that going to actually look like? Well, we are going to have the limit as h tends to 0, 5 bracket x plus h squared, because we had an x squared over here. That's where the squared actually comes from, minus our function f of x, which was 5x squared, all divided by h. Now, we are going to have to, of course, expand the double bracket that we have. So, limit as h tends to 0, 5 bracket, and that's x squared plus 2xh plus h squared minus 5x squared, all still divided by h. Now I'm going to multiply this out with everything over here. Okay, so let's carry on. The limit as h tends to 0 is 5x squared plus 10xh plus 5h squared minus 5x squared, all divided by h. Okay, first thing I'm seeing is this. So we can actually cancel this and that out. Okay, over here I can actually factorize that. So this is the limit as h tends to 0. Let's take a 5h outside, leaving me with 2x plus h, all still divided by h. Okay, so if that's the case, then I can actually cancel this out with that. And then this, of course, just becomes, if I was to re-expand that, 10x plus 5h. Okay, now, as h tends to 0, essentially this eventually goes to 0. So this becomes 10x plus 5 times 0. So therefore, the answer is just 10x. And that's differentiating 5x squared using first principle. So the answer to this, of course, is just 10x. You don't always have to do this. We know simply we take this, we multiply that, and take a power away. But in case they ask you to differentiate from first principle, this is exactly how it's done.